Okay, so we're trying to find the absolute maximum and minimum of this polynomial. And so what I'm going to do is I'm going to do a little division here, and we'll put the steps over here. And I'm just going to summarize them. But the first step that you're going to do is you're going to find the critical points. And so remember, to find the critical points, you find where the derivative is equal to 0 and does not exist. So that's the first thing we do. So let's find the derivative. So this is a pretty easy derivative to find. It would be minus 2x plus 10. We set it equal to 0, so there's no spot where this is undefined. And we would get that x is equal to 5. Okay, so this is the only critical point that we have. And so then the second step is you're going to plug in and compare. We're going to compare the y values for the endpoints. So we're going to plug in the endpoints and the critical points. Now in this case there's only one, but if there was more than one, then we would do that. So step 2 is you basically grab the endpoints, which are 3 and 8, and then you're going to grab the critical point 5, and we're just going to plug each one of those into the function, and the biggest will be the absolute maximum and the smallest will be the absolute minimum. Easy, right? Okay, so let's do it. So if I plug in 3 into my function, I would get minus 3 squared plus 10 times 3 plus 43. And this is equal to 64. Okay, the next one, if I plug in 8, I would get negative 8 squared plus 10 times 8 plus 43, which is equal to 59. And then the last one, x equals to 5, I have negative 5 squared. Be careful with that negative. Make sure you don't put it inside of that parentheses. Plus 10 times 5 plus 43, which is 68. Okay, so then you just look at all three of them and you say, okay, well, the absolute maximum is this one, 68, and it's located at x equals to 5. And the absolute minimum is going to be 59, and it's located at the right endpoint, x equals to 8. Okay, so here we're trying to find the absolute maximum and minimum of this function, sine of x times cosine of x, on the interval from 0 to pi over 2. First step, remember, is to find the critical points. So that means that I have to find the first derivative. So the derivative of this function, I have to use the product rule. So I have the derivative of the first, which is cosine of x, times the second, leaving it alone, cosine of x, plus sine of x, and then times the derivative of cosine, which is negative sine of x. So what I'm going to do is I'm just going to change this to a minus sign. Okay. So this is equal to cosine squared x minus sine squared x. Okay. Now you can solve it like this. We set it equal to 0, right? And we want to solve this this function. But you might notice that cosine squared minus sine squared, well, that's equal to cosine of 2x. That's the double angle identity. And so we can just solve this one. Now, we know that cosine, no matter what's inside of here, so we have this 2 here, but we know that for cosine to equal to 0, it has to equal to pi over 2. And since it's 2 times x, I'm going to keep going. Even though my interval goes only up to pi over 2, I'm going to go past it to the next value. Because remember that this 2 here makes cosine go twice as fast. So I might be able to catch that one. Okay, so then what I do is, remember, you set 2x equal to pi over 2, which means that x is going to equal to pi over 4. So that's one of the values. And then if I solve 2x equals to 3 pi over 2, I'll get x is equal to 3 pi over 4. So notice that in this case, even though cosine is going twice as fast, this 3 pi over 4 is past pi over 2. So this isn't actually one of the values I'm going to use. But you always want to go past whenever you have either a double or a triple angle inside of the trig function. So my only critical point is pi over 4. Okay, so then remember what you do is you plug in your critical point. So you compare the value of the critical point or points and your endpoints. And what you're trying to find is the y value. And so you basically do a little comparison. We're going to compare, and we're looking at the y value. So we're going to plug in x equals to 0, x equals to pi over 2. Those are my endpoints. And then x equals to pi over 4, which is my only critical point. And so remember, basically, these are all the possible spots where the absolute maximum and minimum can occur. And so I'll plug in all 3 of these into the original function, and that will give me, I'll just pick the biggest and the smallest, and those would be my maximums and minimums. So let's do that. So here I have f of 0, which is sine of 0 times cosine of 0. And that's just equal to 0. Now if I plug in pi over 2, I get sine of pi over 2 times cosine of pi over 2. And that's also equal to 0. And last but not least, I plug in pi over 4, and I get sine of pi over 4 times cosine of pi over 4. And each one of these are both exactly the same. This is simply root 2 over 2 times root 2 over 2, which is equal to 2 over 4, or 1/2. So then you go, okay, well, my absolute maximum between these 3 values is y equals to 1/2. So this is the absolute maximum. And the absolute minimum, there's 2 spots where you find the absolute minimum. The absolute minimum is 0, and it occurs at both x equals to 0 and x equals to pi over 2.